Hi, so this is the last experiment, experiment 5. So adding sodium hydrogen sulfite or just sodium sulfite and potassium dichromate together. So we're going to go to the lab and have a look. We're going to have a couple of mils of, I've put here sodium hydrogen sulfite, but I think in the lab I've actually just got sodium sulfite, Na2SO3. And then we're going to add a few drops of acidified potassium dichromate. Now, in order to double check what we actually have got, we'll make some observations, but we're expecting to make some sulfate ions. So we're going to use some barium just to double check if there are any sulfate ions present. Because if they are, the barium will react with it and cause a white precipitate. You may be familiar with that from your ions internal, if you did ions. So let's go to the lab and do the experiment, and then we'll come back and do the write-up. Okay, so here we are with another experiment. We're going to add some sodium sulfite or sodium bisulfite, could be sodium hydrogen sulfite. All we're looking for is some SO3 2- ions there. That is a clear and colourless solution. And we're going to react it with some potassium dichromate. This is a beautiful orange colour. So what I've done is I've just popped some in a test tube as a reference for us to see that beautiful medium orange. So all we're going to do is put some of these things together in a test tube. Oh, I've got my white piece of paper there hiding my other experiments that I did before, just so you don't get confused. And so then we're just going to add a couple of drops of this potassium dichromate. Just enough to give it some colour. So here's us with just some sodium sulfite and a couple of drops of orange potassium dichromate, because we only added a couple of drops. It looks a little bit more yellow than orange. But we're going to let that sit for just a minute, and we'll see what happens to the colour after a little while it's been given time to react. So I hope you can see that this is now gone slightly green. It's not kind of a clear yellowy orange anymore. It's actually gone a little bit like a lime green, which can be hard to see if you haven't got something like a white background to put it on. So it has gone a little bit darker. And what you can do as well is just do another experiment, and so after giving it a minute or two, do a fresh experiment, see what the original colour really did look like in your test tube. So we've seen the orange potassium dichromate turn to more of a green colour. So that indicates a certain species. We'll go back and do the write-up for this one. So just a side note, if you want to confirm what you've actually got in here, so you've got a green chromium species in there, but what else have you got in there? The sulfite ions should have changed into sulfate ions. If you've done the ions internal, you'll know adding a bit of barium will form a precipitate. So if we do have sulfate ions in there, we will see a white precipitate form. Oh la la, look at that. Great result. All right, so taking those observations from the lab, let's write them down. What did we see? So we had a colourless sulfite solution, okay? That didn't change colour, but as we added orange Cr2O72-, orange dichromate changed colour. We had a colourless and clear solution of, in this case it was Na2SO3, that's fine. We saw a green solution forming. That was because of the presence of Cr3+ ions. And we also, you don't have to write down the observations per se, but you also said that you could have a positive test result for the presence of sulfate ions. All right, that's what we saw if we had our white precipitate formed on addition of barium ions. Cool. So what's going on here? Let's try. Let's have a look. Again, just like the purple potassium permanganate, this orange potassium dichromate is a very popular oxidant. So it is going to make something else get oxidized, in this case, the sodium hydrogen sulfite. So I like to think of sulfite ions just as SO3 2- ions. Some people may have hydrogen there, so it'd be HSO3 1-, but I like to just think of sulfite ions. And they are going to change into what we did note was present, sulfate ions. Now, how do we balance this equation? It's just one oxygen difference, so we need to add an oxygen on this side in the form of water. That means we've added 2 hydrogen ions. We need to balance that out. There's a 2- charge here. There's actually a 0 charge overall here. So we're going to add our 2 electrons here, and that balances our charges for us. So this is the oxidation. In terms of reduction, we've got, again, you're probably going to be familiar with this by the time you finish. Leaving some space, 2 Cr3+, because there were 2 there, right? So we have 2 chromium species. 7 oxygens are going to come on this side in the form of 7 waters. That means we've added 14 hydrogens. And on this side we have -2 and +14. That gives us a +12 charge. Here we have a +6 charge because we've got 2 lots of these 3+. So this is going to have to come down by 6. So we can add 6 electrons here to bring that number down. And then our charges are balanced. Yay! So hope that's okay so far. Let's have a look at what the overall equation would look like. We have 2 electrons here, 6 here. So we could triple this and that would give us 6 electrons. Oh, triple it, give us 6 electrons. And then those electrons would cancel. We'd also get 6 hydrogens here and 14 on the other side. So we're going to end up with just 8 hydrogen ions here. They will cancel as well. So I might just circle that to remind myself. So let's write our full balanced equation. 3 lots of this. 3 lots of waters. Oh, waters will also cancel. So we had 3 lots of waters. That would cancel that. That would end up being a 4. So I'm not going to write water there. Chromium, Cr2 dichromate, 7 2-. Now these hydrogens, 6 of them were going to be cancelled, so it leaves us with 8 hydrogen ions. The electrons we know will cancel, because that's why we're doing this. That's everything on this side. 3 sulfates, so 4 2-. There's a difference, right? We have already dealt with the hydrogens, we've already dealt with the electrons, we've already, oh no, here we go, we've got 2 chromium ions. And these waters, so there's going to be 3 on that side that cancelled and just left us with 4. There we go, what a doozy. Nice. So that's most of it. Now we just have to justify what was happening here. So depends how you want to think of it. I always like to think of redox in terms of electrons or oxidation numbers. So in terms of electrons, each sulfite species was losing 2 electrons to become sulfate. So each SO3 2 minus lost 2 electrons to become SO4 2 minus. And so losing electrons is oxidation. Or you could say with the dichromate, each dichromate gained 6 electrons. To become 2 Cr3 plus ions. So if you're thinking about what each chromium actually did, it's probably more specific to say that each Cr species, the Cr species here, gained 3 electrons to become, a Cr3 plus species, because we had 2 of them happening, right? So these 6 electrons were actually spread over these 2 separate chromium species. These chromium kind of like, not atoms, nuclides, whatever. All right, and so again, of electrons is reduction. I prefer oxidation numbers, so let's look at the oxidation numbers. So here, oxygen is -2. There are 3 of them, so it gives us -6. We need to have an overall the overall balance come out to be -2, same as the ions charge. So the sulfur atom here needs to have an oxidation number of +4. Same on this side, except now we've got 4 oxygens. So it's actually a -8 going on there. To get to a -2, that needs to be +6. So our sulfur species, okay, so this is sulfite, this is sulfate, but the sulfur has gone from an oxidation number of, well, the S in sulfite has gone from an oxidation number 4 to an oxidation number of 6. So SO3 2 minus has oxidation number of, what did we say, +4. This increased to +6 in SO4 2 minus, and as we know, an increase in oxidation number indicates oxidation has occurred. The dichromate species here, in terms of looking at the oxidation number, oxygen again has a -2 oxidation number, and there are 7 of them, so that's kind of like a -14 there. We have 2 chromiums, and we need to get the total oxidation numbers to balance out to a -2. So I think about, well, if I had -14, -2, I need to have like some +12 here. So each chromium is going to be +6 oxidation number. Here, each chromium species is going to have an oxidation number of +3 as per the ion. So that's a bit more straightforward. Remember though that there are 2 chromiums here, and we've already talked about that in terms of electrons. So the Cr species in Cr2O7 2 minus has an oxidation number of +6. This is going to decrease to an oxidation number of +3 in the Cr3 plus species. So hope that helps you to just get a bit more experience and a bit more practice. Talk to your teacher if you want to do any more, or if you want your teacher to check over some of your work. Thanks so much for watching.